Hey everybody, welcome back to another video for college algebra. This is section 1.2, linear equations and rational equations. And we're not going to get super complicated with the rational side of things, but the basic linear equation stuff, again, this is stuff you probably have seen before. Just going to go through some things with you, make sure that it looks familiar, and then show you a couple of slightly more complicated examples that maybe you haven't seen in your previous experience. So we're going to go through a lot of stuff here. I'm going to talk about solving linear equations in one variable, equations that contain fractions, solving rational equations where the variables are in the denominator, and then talk about some terminology associated with these guys. All right. So a linear equation is simply an equation that can be written in the form, it's not given this way necessarily, but it can be written in the form of ax plus b equals 0, where a and b are real numbers. A is not 0, or else the x would go away. Okay, and so understand what the process is here. If we subtracted b from both sides, we would get ax equals negative b, and then if we divided both sides by a, you'd get a solution for x, as long as a is not 0. Negative b minus a is a number, and so that's kind of the process that we do. But before we can do this process, these are like the last two steps. Get the x's on one side, the constants on the other, and then divide. Those are the last steps, but we need to simplify before we can get there, and so that's often what we need to work on. Okay, so this is how to generate equivalent equations. You can add or subtract things, the same number on both sides, the same variable on both sides. You can multiply or divide by the same number or quantity on both sides as long as it's not 0. You can flip both sides of the equation, or you can simplify one side and distribute or remove, grouping, combine like terms, whatever. So all of these things you can do, and it doesn't change the value of your variable at all. Okay? And so to solve a linear equation, here are the 4 steps. All right, I'm going to keep going. If you guys want to pause it at this point and write these down, that's great. Okay, so we're going to take a look at an example here. We have 4x as the only variable. I've got it underlined. We've got 5 and 29 as your two constants, and so we want to get the constants on the other side by themselves. So we're going to do the opposite. I don't want you to think of moving things. I want you to think about of undoing the operation. So if you're going to have a plus 5 on this side, you want it to go away, that's subtracting 5. That's the opposite of plus 5. If you subtract 5 on one side, you got to subtract 5 on the other. Okay, so we subtract 5 from both sides. When we do that, we're left with, on the left-hand side, 4x by itself. On the right-hand side, 24. And now to get rid of the 4, that's 4 times. The opposite of 4 times is 4 divided by. So we divide both sides by 4, and we're left with x equals 6. Okay. Now, the textbook asks you often to check your answer. I'm not going to require it necessarily. Obviously, if in a homework or a quiz they ask you to check it, then you're going to have to show that. But if you do check it, that just means go back to the original equation. You have to go back to the original. You can't check it down here somewhere. You got to check it in the original equation. Plug in x equals 6, and then figure out, is that a true statement? And obviously 29 is equal to 29, so yes, it is a true statement. Okay, so this kind of thing, guys, I do assume that you know how to do. And I'm not going to spend any more time on that. You should practice and make sure you're good. Okay, now, if you want to deal with a linear equation that has fractions, notice this is still a linear equation. There are no denominators with x's. Okay. So that's still still a linear equation, not a rational equation, but linear. And so what we're going to do is we're going to eliminate the LCD first. So we're going to multiply everything by 28, because if you have a 4 and a 14 and a 7, 4 is 2 times 2, this is 2 times 7, and this is just 7. So we take the highest power of the 2, and we take the highest power of the 7, and we get 4 times 7, which is 28, and that's the LCD. And that's how you do it. We talked about LCDs with the rational equations in P6. And so we're going to take the 28, we're going to multiply everything by 28 on both sides of the equation. That's allowed. So we multiply everything on both sides of the equation by 28. When we do that, okay, what happens? Well, 4 divides into 28, leaves a 7 right here. There's a 1 left in the bottom. 14 divides into 28, leaves a 2 with a 1 in the bottom, and then 7 goes into 28 4 times with a 1 in the bottom. Don't forget your parentheses here. And all the denominators are now eliminated. All right, so what does that look like then? That looks like this. 7 times x minus 3 equals 2 times 5 minus 4 times the group x plus 5. Distribute. That negative sign carries through. Negative 4x minus 20. 7 carries through. And now what are we going to do? 10 minus 20 is negative 10. Combine like terms on the right-hand side. What needs to happen now? We need to add to get this 4x to the other side. We need to add to get this 21 to the other side. So what are we going to do? We're going to add 4x to both sides right here. We add the 4x to both sides. Negative 4x plus 4x is 0. You get 4 plus 7, which is 11. We add 21 to both sides. That gives us 11x here and 11 over here. We divide both sides by 11 and get x equals 1 as your final answer. Okay. And so it's the same process that you did with linear equations. There's one extra step, which is getting rid of the denominators. That's the first step you need to do. Again, if you want to check your answer, you plug in 1 everywhere and see if you get an equivalent thing, and negative 1/2 equals negative 1/2, so it checks. Okay. Now, I want to show you an alternative method, because that multiplying by both sides by the LCD is not the way that I recommended you to handle simplifying complex fractions, multiplying top and bottom. I'm going to start here as well, saying that there's another option, and the other option is that you work with each side separately first. So I'm going to look at this side only and say, what's the LCD over here? Well, the LCD over here is 14. 7 times 2 is 14. So we're going to leave this side like it is, and over here we're going to change to 14s. So I need a 2 on top, because 2 times 7 will give me 14 in the bottom. And so now what can I do on the right-hand side? I can combine into one big fraction because I have the same denominator. Distribute your negative 2. All right, you get x minus 3 over 4 equals 5 minus 2x minus 10 over 14. And of course that simplifies to x minus 3 over 4 equals negative 2x minus 5 over 14. So what do I do now? What I do now is I do what's known as cross multiplication. Remember that cross multiplication is not actually a thing. It is a shortcut. It is a shortcut, right? So what you're really doing is you're multiplying both sides by 14 and both sides by 4 at the same time. But if I do cross multiplication, that tells me that 14 gets multiplied by the x minus 3. The equals is still here. The 4 gets multiplied by the negative 2x minus 5, that direction. And now we distribute and simplify. Okay, so this is going to take a little longer than the other method did. 14x minus 42 is negative 8x minus 20. We're going to add 42 to both sides to get rid of the constant. That gives us 14x equals negative 8x plus 22. We're going to add 8x to both sides. And what does that do for us? That gives us 22x equals 22. And then if we divide both sides by 22, to get x by itself, we get the same answer. We get x equals 1. We've already checked it. We don't need to recheck. All right, but that's the idea. It's a little bit slower process, but it definitely does not give yourself to as many shortcut mistakes, if you will. So either one of those is a fine way to do it. All right, and make sure you do plenty of practice there. Okay, so now as we move into rational equations, we have the same idea. We can do it the shortcut method, which is multiply everything by the LCD, or we can solve the left-hand side, solve the right-hand side, and then do cross multiplication. Okay, I am going to go ahead and just follow along method given here. We're going to solve this equation. All right, now the first thing you have to do is make sure the denominator doesn't equal 0, so we have to notate that x is not allowed to be 0. All right, first. And then when we go to solve this, we do look for the LCD, right? We look for the LCD. We've got 2x, 3x, and 18, which is 2 times 9, which is 3 times 3. And so the 9 includes this 3, the 2 includes this 2, so we get 18, and then these each have an x, so we get an 18x as our LCD. That should be something you can do by this point. And if we multiply both sides by the LCD, like they suggest, then what happens? What happens is we simplify. Here, 18x divides away with 2x and leaves a 9. The x's are gone, leaves a 1 on the bottom. Here, 18 divides 18, leaves the x. Here, 18x divides with a 3x, leaves a 1, and there's a 6 up top. Okay, so that's what happens. If you follow after that, then you'll see that you get 9 times 5 equals x times 17 minus 6. Simplify and add 6 to both sides. Okay, if you add 6 to both sides right here, right, you're going to get 51 over 17x, and then divide everything by 17 to get x equals 3. Now they did take this to the other side. It doesn't really matter, all right, but that's just that's probably a little bit confusing. If you have 51 equals 17x, we'll divide both sides by 17, and so you end up with 3 equals x, and x equals 3. That's the same thing, obviously. Okay, so that's your answer. You want to check it, go back and check it in the original equation. Okay. So the last piece here that I want to talk to you about there are 3 types of equations. There's a conditional equation, an identity equation, and an inconsistent equation. Conditional is what we've been working on so far. Conditional is where at least one number. We've only had ones that have one answer. Sometimes though, if you remember back from like high school algebra or whatever, when you factor, for example, if you factor to solve a quadratic equation, you'll get 2 answers sometimes. And so it's possible to have more than one real answer, but you have to have at least one, then it's conditional. If you find an equation that's always true for all real numbers, then it's called the identity. And if you have an equation that's never true, it's called inconsistent. So let me show you an example of these two. You've been seeing examples of conditional already. What would an identity look like? All right, an identity looks like this, where we start off with 7x plus 9 equals 9 times x plus 1 minus 2x. All right, if we take this 9 and distribute it, then what do you get? You end up with 7x plus 9 equals 9x plus 9 minus 2x. And then if we combine those guys, all right, then we end up with 7x plus 9 equals 7x plus 9. And if you subtract 7x from both sides, you get 9 equals 9. As soon as all the x's are gone, right, if all the x's disappear, then you've got one of two things. You've got an identity equation, which is this, because that's always true. This is always true. Or you end up with something that's never true, and that's called an inconsistent system, or an inconsistent equation, excuse me. So always true is identity. The solution for this then is what? Well, if it's always true, then x is any real number. Right? X can be all real numbers. But if you have a system like this, an equation like this, distribute the 4, okay, but then we get 4x minus 7 equals 4x minus 3 plus 1 plus minus 4 plus 3. Subtract 4x from both sides, and you get -7 equals -1. That's never true. False statement, no x's in there. This is what's known as inconsistent. And so with an inconsistent, you just write no solution. Or shorthand for no solution is 0 with a line through it. That's called the empty set, which means your set of solutions is empty. There are no solutions. Okay? Either one of those is fine. Okay? So I hope that helps. And as always, reach out if you have any questions. See ya.